Beneath the vast, shimmering surface of our planet's oceans, a world of profound mystery and immense power exists. Here, in the crushing darkness of the deep, glide some of humanity's most formidable creations. These are the nuclear submarines, colossal titans of steel and ingenuity. They move with a silence that belies their immense capabilities, unseen, unheard, yet ever present. They are the silent sentinels, patrolling the abyssal plains, a constant, watchful presence in the global theater. Their very existence speaks of power, of deterrence, and of the remarkable human drive to conquer even the most inhospitable environments on Earth. These incredible vessels are more than just machines. They are self-contained worlds. They navigate through underwater canyons and across vast, unexplored territories, relying on technology that pushes the boundaries of science. The nuclear submarine is a product of decades of research and development, representing a pinnacle of engineering. To truly appreciate these underwater titans, we must first understand what sets a nuclear submarine apart. At its core, a nuclear submarine is a submersible vessel powered by a nuclear reactor. Unlike their predecessors, the diesel-electric submarines, these vessels do not need to surface or use a snorkel to run diesel engines to recharge their batteries. This single difference revolutionizes their operational profile, granting them an almost limitless underwater endurance. Diesel-electric submarines, while still effective for certain roles, operate on a different principle. They rely on diesel engines to power them on the surface and to charge large batteries. When submerged, they run on these batteries, which have a finite life. This means they must periodically surface or come to periscope depth to run their engines, a process known as snorting. The nuclear submarine, therefore, is a true submarine, designed to live and fight in the depths. The advantages conferred by nuclear power are manifold, including speed and the ability to remain sealed from the outside atmosphere. This autonomy allows for extended submerged patrols, making them the ultimate stealth platforms. The nuclear reactor aboard a submarine is a marvel of compact engineering, a powerhouse designed to operate reliably in the most demanding conditions. At its heart lies the reactor core, containing precisely arranged fuel elements, typically enriched uranium. Within these elements, a controlled nuclear fission chain reaction takes place. This process is meticulously controlled by neutron-absorbing control rods, which can be inserted or withdrawn to manage the rate of fission and thus the power output of the reactor. This intense heat generated by fission is the primary product of the reactor. It is used to heat a primary coolant, usually highly purified water, which is kept under high pressure to prevent it from boiling. This superheated primary coolant is then pumped through a heat exchanger or steam generator. In the inky blackness of the deep ocean, where sunlight cannot penetrate, sight is of little use. Here, sound reigns supreme. For a submarine, its eyes are its sonar systems, an acronym for sound navigation and ranging. These sophisticated acoustic sensors are vital for navigation, for detecting other vessels, and for avoiding underwater obstacles. Sonar technology allows the submarine to paint a picture of its surroundings using sound waves, much like a bat uses echolocation to navigate in the dark. Sonar systems operate in two primary modes, active and passive. Active sonar is akin to shouting in a dark room and listening for the echo. The submarine emits a pulse of sound, often called a ping, which travels outwards. If this sound wave encounters an object such as another submarine, a shipwreck, or the seabed, it reflects back. Sensitive hydrophones, essentially underwater microphones, detect these returning echoes. By measuring the time it takes for the echo to return and the direction from which it comes, the sonar operators can determine the range, bearing, and sometimes even the nature of the object. Nuclear submarines are not merely feats of engineering, they are potent instruments of national power, carrying a formidable array of weaponry designed for a variety of missions. Their primary role, particularly for ballistic missile submarines, is strategic deterrence. These colossal vessels, often referred to as boomers, carry long-range submarine-launched ballistic missiles tipped with nuclear warheads. The very purpose of an SSBN is to remain undetected for months on end, providing a nation with a survivable second strike capability. Attack submarines, on the other hand, are designed for a different set of tasks, though equally vital. These are the hunters of the deep, tasked with seeking out and, if necessary, destroying enemy surface ships and other submarines. To achieve this, they are typically armed with advanced torpedoes, such as the Mark 48, which can be guided towards their targets with remarkable precision. The journey towards the nuclear submarine began in the fervent post-World War II era, a time of rapid technological advancement driven by the burgeoning Cold War. The limitations of diesel-electric submarines were well understood. Their need to surface to recharge batteries made them vulnerable. Visionary minds sought a power source that could free submarines from the tyranny of the air-breathing engine. The answer lay in the newly harnessed power of the atom. The United States Navy, under the pioneering leadership of Admiral Hyman G. Rickover, championed this revolutionary concept, overcoming immense technical challenges and considerable skepticism. The culmination of these efforts was the USS Nautilus, launched in 1954. Her commissioning marked a profound turning point in naval history. Nautilus was the world's first operational nuclear-powered submarine, and her capabilities were astounding. In 1958, she achieved what was previously unthinkable, a submerged voyage from the Pacific to the Atlantic, passing beneath the Arctic ice cap at the North Pole. This historic journey, codenamed Operation Sunshine, dramatically demonstrated the global reach and underwater endurance that nuclear power bestowed. Nautilus shattered existing submarine speed and endurance records, heralding a new age of undersea warfare and exploration. The Cold War era was the crucible in which modern nuclear submarine operations were forged, a period marked by both extraordinary achievements and sobering disasters. The relentless pursuit of technological superiority led to incredible feats of engineering and endurance. Submarines from both NATO and Warsaw Pact nations conducted continuous patrols, often in close proximity, testing each other's defenses and resolve. These silent duels beneath the waves were a constant feature of the superpower rivalry, a hidden front line where intelligence was gathered, and capabilities were demonstrated without, for the most part, escalating into open conflict. The skill and professionalism of the crews on both sides were paramount in preventing incidents from spiraling out of control. However, the inherent risks of operating such complex machinery in an unforgiving environment sometimes led to tragedy. The loss of the USS Thresher in 1963, with all 129 souls aboard, was a stark reminder of these dangers. The disaster, attributed to a flooding incident linked to a piping failure, led to the implementation of the rigorous SubSafe program in the U.S. Navy, drastically improving submarine design and safety standards. Similarly, the Soviet Navy experienced its own share of accidents, often shrouded in greater secrecy at the time, but highlighting the universal challenges of operating nuclear submarines at the edge of technological possibility. Life aboard a nuclear submarine is an experience unlike any other on Earth, a unique blend of close confinement, demanding work, and profound isolation from the outside world. For months on end, a crew of over 100 individuals lives and works within the steel confines of the hull, deep beneath the ocean's surface. Space is an absolute premium. Every inch is meticulously planned and utilized. Sailors, or bubbleheads as they are affectionately known, share cramped sleeping quarters, often hot bunking, where one crew member occupies a bunk while another is on duty, then they switch. Privacy is a rare commodity in this metallic, self-contained ecosystem. The psychological challenges are significant. Deprived of sunlight, fresh air, and the normal rhythms of day and night, the crew must adapt to an artificial environment. The submarine maintains its own internal clock, often based on a 3-watch system, with sailors typically working 6 hours on, followed by 12 hours off, though this can vary. Maintaining morale and cohesion is vital. Regular routines, training drills, shared meals in the small mess, and recreational activities like movies or card games in limited common areas help to break the monotony and foster a sense of community. The story of the nuclear submarine is far from over. These silent giants are evolving to meet new challenges. As global maritime activity increases, the stealth, endurance, and firepower of nuclear submarines ensure their continued relevance. Engineers focus on quieting technologies to evade sophisticated detection methods. Innovation in hull design, propulsion, and sound-dampening materials drives the quest for ultimate stealth. Future submarines will likely incorporate more automation and artificial intelligence. Unmanned underwater vehicles will extend sensory reach and operational capabilities.